So obviously I'm here to discuss my project for DS4100. The idea I had for my project was I wanted to use cars and somehow not be cliche because, as you know, we've all used R, every data set in there. I mean, there's cars, empty cars. It's just a really common cliche to me, and I wanted to do something with cars, but have it be different. So instead of just using the basic, passenger car values like, the number of doors and, I don't know, displacement or whatever, I wanted to do something that involved racing specs and how well the car performs on a track. So if we move on to the first step of CRISP DM, the business understanding. So I play a video game called Forza. It's a racing simulator. Not ashamed of it. It's an absolutely amazing game. And I also am a big fan of Car and Driver, the magazine and online publication. So basically, Forza has a rating system. So they rate every car they have in the game. I want to say there's 700 cars, something like that. And they rate them based on speed, acceleration, handling, all kinds of things, and then they slap them with an overall rating, like 1 to 1,000. Car and Driver, if I show you this web page here, has a web page for every lightning lap they've done. So they've tested more than 200 cars on Virginia International Raceway. You can see it here. And then they've posted the name and the make, model, year of the car, and then the time that it recorded its fastest lap on that track when they tested it. So what I wanted to do was use the Forza ratings, which I found in a spreadsheet by a Forza moderator here. So you can see all the ratings: speed, handling, acceleration. What is that? The launch, that's not even there for all of them. I didn't use that one. But there's a ton of stats in here, and some of these real life specs too, like horsepower and torque and weight. So I wanted to basically take all of those features and decide what factors contribute to better lap times. So as far as data understanding, I had to do cross comparison between the two sets I wanted to integrate just to see which vehicles actually existed in both, because if the make, model, and year aren't exactly the same, obviously then that's not going to be relevant. It has to be exactly the same car in both sets. There were certainly some imperfections, namely the years were really annoying. Obviously, when you're going to integrate two sets, you're going to run into problems like this. But basically, what happened is in the Car and Driver set, they would use the model year of the car, which would be 1 year earlier than the pre-release, like the auto show reveal year of the car. And Forza thinks it's cool and likes to use the auto show reveal year, so obviously there was a 1 year discrepancy between a lot of them, but not all of them between the two sets. So I had to go through and look for those. And the naming conventions were slightly different because, again, Forza, if you look at something like, let's see, let's find the Camaro. That is Camaro. That is not right. So see how right here you get Camaro Gen 6 ZL1. Gen 6 is not part of the name, it's just the generation of the car. So obviously Car and Driver doesn't include things like that, Forza does. So looking for things like that, again, also annoying, messed up the ordering, messed up the matching. So I had to think about things like this going into it. And as far as the actual preparation, this was, as I've prefaced, absolutely the hardest part. I had to select which vehicles were in both sets. I had to select which features were relevant because a lot of them absolutely were not. I had to do some feature engineering because I wanted features like the weight to torque ratio, weight to horsepower ratio, as well as I did dummy codes later on when I was building my second model, but I'll get to that. I had to do some text parsing as well because I'm going to show you why actually by pulling up the code. So let's see, let's just run through this quick. Just run all these chunks. That's loading the Excel. And then I'll scrape from Car and Driver with the custom scraper. Okay, so look at these two formats. We get make, model, and year out of the Forza Excel sheet. And from the scraper, we get make, model, and year in one column, which is obviously not going to work. So I had to parse each of these entries here and split them into 3 columns and convert the years from a character to a double. So if we just run this, you can see we split it into make, model, and year, and that ended up working out really well. So just things like that were pretty common. It's definitely the hardest part. And then I had to integrate by actually matching all the rows up. Data storage I'm not going to go into too much. I didn't find it very necessary to use a database for this project because I didn't really have a ton of data. My data set ended up being, I want to say, 65, 67 cars once I found out which ones actually matched up. But I did use a SQLite 3 database to demonstrate the knowledge of using one. Retrieval from R, I used the rvest package to just kind of plop my data frame into a table and get some stuff back out. As far as the modeling, this part was really fun because if we go back to our business understanding again, I really wanted to find out what actually makes a car have a better lap time and use data to do that. So I used backwards elimination. I made 2 multiple regression models. So the first one, I started with only the numeric features. I didn't do categorical because they really weren't proving to be significant with a full set, so I figured I'd try to do something with that later. So as a starter, I just used numeric features. And the result was that we got lap time as a function of the year of the car, its rating in Forza, its handling rating, and the ratio of weight to horsepower. So all of these things are the significant contributing factors to a car's lap time in this model. You'll notice 2 of these are in-game ratings. Forza derives these. I didn't want to do that. And weight to horsepower ratio is actually a real spec, so it's combining those 2 things. And it's a pretty strong model. We get a 0.9405 adjusted R squared, pretty small standard error, and the MSE around 29-30,000. The second model I wanted to include categorical features, so I made some dummy codes for engine configuration and drive type. So this is just basically whether the car is driven, gets power to the rear wheels, all of the wheels, or just the front wheels. The configuration of the engine is either going to be a flat engine, an inline engine, or a V-shape. And those things can both contribute to how well a car gets around the track, so I wanted to see how they factor in. And it turns out that we lost the handling from one model to the other. It was replaced by speed, so speed became significant, and the inline component of engine configuration also became significant. And we got a pretty similar model, very similar MSE standard error and adjusted R squared, but the models do have their differences. So for the evaluation, I compared the MSEs. The MSE of the second model is slightly higher. Again, for R squared, the R squared of the second model is also slightly higher, and the standard error of the second model is slightly higher. So the second model has a little bit higher of an MSE, so it's maybe not going to predict the values as spot on, but it has a smaller prediction interval because I made confidence intervals for both of these with a car of my choice, which was the Mercedes SLS AMG. And as a result, I really trust the second model more because personally I think the point of a regression is more that interval. There's a smaller interval of the prediction, so it's going to be more accurate, at least in my opinion. For the evaluation step, the significant factors, and this is really what we wanted to determine from the business understanding, what factors do contribute. So overall, across both models, Forza rating, year, and the weight to horsepower ratio can predict it. And depending on the model, we also got handling rating, engine configuration, and top speed showing up. So yeah, that's pretty much my project. If we wanted to run maybe a little bit more code, I can definitely do that. So I just have to step through some of these here. And I want to get to when I first run the first model. So a lot of this was just cleaning, exploring. It's a pretty long file. You can hear my computer crying right now. Actually, you might be able to hear that airflow. It's pretty loud. These are some exploratory plots, so you can see kind of the linear correlations that were showing up before I even did any modeling. I'm going to skip the storage section for now. And if we just run this, so you can see this is the output of when I first ran the model without any tuning, elimination, anything. But we still get a pretty high R squared, just needed to eliminate all those features. But yeah, that's basically the project. So feel free to leave comments or feedback, and I appreciate it.